everyone. In the previous video lecture, we already discussed regarding NAS file sharing concept with respect to Windows and Unix permissions, and NAS file sharing authentication along with authorization concepts and Kerberos. So in the present session, we'll discuss regarding IP/SAN, security at the network level and the security at the storage level in detail. The security mechanism used with respect to IP/SAN environment is the challenge handshake authentication protocol. So we can secure IP/SAN by considering CHAP, that is challenge handshake authentication protocol. So which is a basic authentication mechanism that has been widely adopted by the network devices and the host. So this handshake authentication protocol, which provides a method for initiator and the targets in order to authenticate each other by utilizing a secret code or any password. So these CHAP secrets are usually random secrets of around 12 to 128 characters. So either the secrets used may be either varies from 12 to 128 characters. So these may be either the secret code or a password. So here in the diagram we can observe that we are having one initiator device and one more is the target device. So initially, in order to perform the authentication between initiator and the target, initially an initiator will initiate the task by sending a login to the target. So here we use the target array as iSNS storage array. The target device is nothing but iSNS, the storage array. So initiator will try to log in to the target. So now from the target side, during step 2, so it will send some information, that is challenge handshake authentication protocol challenge, which is sent to an initiator by the target device. So it will send some informations to the initiator. So now at the initiator side, so those informations will be received by the initiator and it will calculate one-way hash function. So it will compute the hash value, that means it will compute or calculate value, that is hash value, using one-way hash function. So now during step 4, that hash value will be transferred to the target device. So now the target has the hash value of an initiator device. So now the target will compute the expected hash value from the shared secret key, as well as it will compare the value received from the initiator. So what exactly the target does? So it will compute the hash value by considering the secret information or secret key or password, and later it will compare the hash value with the initiator. So whenever the hash value would send from the initiator to the target, as well as the computed hash value, if it is matches, the authentication will take place. That means if the value matches, authentication will be acknowledged. So this is how in the case of IP/SAN we can establish authentication between initiator and the target device. iSNS discovery domains, it works same as FC zones. So it is same as the functionality is same as FC zones. So you can observe that we are having one discovery domain over here and another discovery domain over here. So the discovery domains provides functional grouping of devices in an IP/SAN. So functionally we can group the devices within one discovery domain, and while communicating, in order to communicate with another device, so at that instant they must be configured in the same discovery domain. So configuration is necessary in order to communicate within the domains. So this is how we can provide securing IP SAN with iSNS discovery domains. So within the domains, the devices can communicate with each other, and those devices need to be configured in the same discovery domain. Securing storage infrastructure in virtualized and cloud environment. So we discussed regarding security threats and how we can provide the security with respect to traditional data centers. So these threats and measures are also applicable for virtualized and cloud environment. So in the case of virtualized and cloud environment, there may be a chance of additional threats as well as additional attacks. Why? Because those there is no control over the cloud resources, and that means a lack of control over the cloud resources, I can say. Lack of control over the cloud resources. And one more thing, this cloud may be either public cloud or private cloud. So we are having some set of limited control over the resources. Therefore, there may be a chance of an attack on the cloud platform. So since we have to consider some key security concerns like multi-latency, velocity of attack, information assurance, and data privacy. So what is the meaning of multi-latency? So multi-latency allows multiple independent users to be serviced using the same set of storage resources. The same set of storage resources can be accessed by multiple independent tenants. So similarly, we are having velocity of attack. What is the meaning of velocity of attack? Velocity of attack is nothing but a situation in which any existing security threats in the cloud spreads more rapidly and has a larger impact than the traditional data centers. So it is nothing but the situation in which the existing security threats in the cloud spreads more rapidly. So the security threat is spreading more rapidly, and which may give a negative impact on the system. So similarly, we have to provide the data privacy is also a major concern in virtualized and cloud environment. So we have to maintain the privacy of the data or secrecy of the data even if the data is located within the cloud platform. So the multi-latency and velocity of attack, information assurance, and data privacy are the key security concerns with respect to virtualized and cloud environment. So next we'll take security measures. So security measures can be implemented at the compute, network, and storage levels. So we can impose different types of security measures with respect to compute platform, network platform, or storage levels. So these security measures implemented at 3 layers mitigate the risk in virtualized and cloud environment. So we have to provide different layers of security so that we can minimize the number of risks with respect to virtualized and cloud environment. So first we'll take security at the compute level. So how we can provide security at the compute level? Securing a compute infrastructure includes enforcing the security of the physical server, hypervisor, virtual machine, or guest operating system. So the compute level, if you are considering the term compute level, so it covers physical servers, hypervisors, virtual machine, or along with the OS. That is OS, guest OS in the sense OS running within a virtual machine. The physical server security involves implementing user authentication and authorization concepts. So in the case of how I can provide security with respect to physical server, so we can adopt authentication or else authorization mechanisms. So these mechanisms identify users users and provide access privileges on the server. So it will allow these mechanisms will identify and provide access privileges on the server. So that is how we can provide security at the compute level. So we can also provide the security by minimizing the attack surface on the server, and we can also consider virtual machine isolation and hardening. So virtual machine isolation and hardening are some of the common security mechanisms to effectively safeguard the virtual machine from an attack. So in order to protect the virtual machine from an attack, we can consider virtual isolation or hardening. So what is the meaning of virtual machine isolation? So virtual machine isolation helps to prevent a compromised guest OS for impacting other guest OS. Virtual machine isolation is implemented at the hypervisor level. So similarly, hardening is a process to change the default configuration to achieve greater security. So we have to change some set of default configurations within the virtual machine so that we can get better or greater security. So next level is security at the network level. So previously we considered security at the compute level. So next we can have the security at the network level. So the key security measures that minimize vulnerability at the network layer are, so we can make use of firewalls, intrusion detection concept, or demilitarized zone, that is DMZ zones. So encryption of data in flight or in the data traffic. So these are the four major key factors can be considered in order to provide the security at the network level. So next, last one is the security at the storage level. How I can provide or how we can give the security at the storage level. Common security mechanisms that protect storage includes the following. So first is access control method to regulate which users can access the data from the storage system. The second method is zoning and LUN masking. And the third method is encryption of data sets, data at rest, that means at the storage, and data in transmit, so while transmitting. Data encryption should also include encrypting backups and storing encryption keys separately from the data. So in the case of storage level, in order to provide the security, commonly we can adopt access control methods. The other one is grouping, that means zoning and LUN masking. And the third concept is encryption of data. So that means on the at rest means on the storage system, or else we can also adopt encryption encryption on the data traffic. And the data encryption should also include encrypting backups. So backup and replica, there are also chance of an attack. So we have to provide encryption for the backed up data and storing encryption key separately from the data. So the last one is data shredding, that removes and trace of the deleted data. So these are the major key concepts we can consider while providing security at the storage